Okay, you can share your screen now.
Yeah. Okay. So yeah, so we had just looked at this uh, abstract domain of interval domain last time, right? So that's where we, I think, stopped off. Yeah. So before I continue, this is where I'll start from. I'll repeat a bit of this slide, but are there any questions about anything that we talked about last time? Okay, good. So then let me just maybe start, and I'll just go through this last example once more, just to repeat some of the points here. See, what's happening here is that we have these two variables x and y, and we are saying that these two variables are going to individually be within these two intervals, right? So x is going to be between -1 and 1, y is also going to be between -1 and 1. Another way to think about this is that the pair of values that x and y can obtain need to be within the set given by the product of these two intervals, right? So we can draw that out geometrically. So we can create, let's say, xy plane, and then we can say that, okay, the actual values of x and y are going to lie in a box that looks like this, right? So this is what the set given by the product of these two intervals is going to look like. It's a box which is aligned with the axis of the x and y plane. So let's say this is my x and this is my y, right? So now what I'm doing is I'm sending, like I'm calculating x plus y and x minus y, right? So let's call these things a and b, and I'm asking, okay, if x and y are going to be within these two intervals, what is the tightest interval that A can have, and what is the tightest interval that B can have, right? And I think everybody last time, multiple people last time calculated this correctly, right? So for A and B, for A, you'll have to take the upper and lower bounds of x and y correspondingly, and then you get the tightest intervals. And similarly for B, you have to take the upper bound of x and the lower bound of y, and vice versa to get the values of the intervals, right? So if you do that calculation, you come up with this thing. So you come up with this fact that A and B, A needs to be within this interval -2 to 2, and B also needs to be within this interval -2 to 2, right? And so what we can then say is that this pair of values given by A and B will be lying within this kind of an interval, right? So now the question is, what does that look like picture in terms of a picture or geometrically? Again, we can draw this kind of an AB plane. And the first thing that we'll do is we'll draw what are the actual values that these pairs of points AB will take. So AB, remember, comes from XY by doing this x plus y and x minus y, which essentially looks like a rotation when you go from the XY plane to the AB plane, right? So what the actual values of x and y are going to look like is if you had taken this kind of a box and would have rotated it so that it looks something like this, right? Where this guy is 2, this guy is 2, this guy is -2, and this guy is -2. Then when we're doing this interval propagation, what we're really saying is that this box is now contained within an axis aligned box that looks like this, right? So when we are doing this interval propagation, we are in some sense introducing some extra points coming from these cornered pieces, and that corresponds to the information loss that is happening, right? So this is the kind of point that I wanted to go for, that even though we have at this point the tightest interval, we cannot make the individual intervals any smaller. If you were to do that, let's say if you make uh, the interval corresponding to B smaller by making its upper bound smaller, then I would lose this piece. And then this kind of like this fact would no longer hold, that if x and y is between -1 and 1, AB would be within the interval, right? So we cannot make any of the intervals any tighter. And yet the tightest interval that we have is actually not tight enough to be precisely capturing the set of values of A and set of values of the pairs of points, set of pairs of values of A and B that can occur, right? So it turns out that in this case, if we use intervals and product of intervals as the abstract domain, right? So if the kinds of sets of values that we're keeping track of are simply just in intervals, then no matter how tight we make it, this is a transformation which we cannot capture precisely, right? So, x, y going to x plus y, x minus y, right? So already we are seeing that with this very simple abstract domain, even very simple transformations involving addition and subtraction are immediately lost, right? So we're already losing some information. And again, why am I saying that we're losing information? We are adding some extra points in which are not there in this in the actual real set, and then that is going to sort of muddle our analysis down the road, right? So when suppose if finally we wanted to prove something like the pairs of values a b will never intersect a region that lies above this line, we will not be able to prove that because we see an intersection over here, whereas in reality there is no intersection with the actual values of a and b, right? So if you were to use this abstract domain for some kind of a proof, something like this could happen, and that things would go down, right? So really, we are losing some information here. Another way to think about what we're losing or what precise information is it that we're losing is that see a and b are not just any values, right? So a and b have a certain relationship between them, right? The way that when I asked the question last time, I asked, okay, for any values of a and b, is it the case that you will have one value of x and y, some values of x and y within this interval, so that a and b comes from that particular value of x and y, right? And somebody said that, oh no, that is not possible because you take 2 as the value for a and 2 as the value for b. That is not possible because the only way 2 can have this value is because is if you set x and y individually to 1 and 1, and in that case b would necessarily have the value 0, right? So this point given by 2 comma 2 is not actually possible, right? So another way of thinking about why this is not actually possible is that when we are saying that a and b can both be 2 comma 2, we're ignoring all of the implicit relationships given by the fact that a comes from x plus y and b comes from x minus y, right? So some of these relationships we can actually write down in terms of equations, and if we do that, we are simply ignoring a lot of these things when we're saying that, oh, all that we can know about a and b is that a is in 2 comma minus 2 comma 2 and b is in minus 2 comma 2, right? So we are ignoring some relationships between A and B, and that is precisely the information that we're losing. And what does that look like in our case? What does this loss of information manifest as? It looks like some extra points that we're carrying around now, right? So these extra points can lead to counter examples, which are not actual counter examples, right? So these extra points will lead to spurious counter examples from the language of abstraction, right? So this is kind of what's going on, and this is kind of the crux of the trade-off in abstract interpretation, right? So now I have a question to you. This is all well and good, but so far from all of these examples, can you come up with a general algorithm to do interval propagation for plus and star, right? So if I have two variables x, y, which are individually, let's say, in a, b cross c, d, then what is the interval x plus y going to be in? Can somebody answer this?
B plus D.
Sorry, come again.
A
I
plus
couldn't hear
A
you.
plus A plus C, B plus D.
Yeah, a plus c, b plus d. Right, and this will always be true. Similarly, so I'm just erasing these diagrams. Similarly, for what about x? Okay, actually, I didn't need to erase this diagram. I can just use this place. What about x, y? Where will that be? It's a bit harder, but
Depends on the sign of the integers also.
yeah, it depends on the sign of the integers, right? So let's do a sort of a case by case analysis just to kind of maybe quickly go through this a bit, right? So again, so we have, let's say, x comma y is in a b cross c d, And we'll have, let's say, 4 cases, right? So let's say that X, Y are both positive. So of course, I don't know anything about A, B, C, and D, right? But I can consider 4 different cases, and then based on that, we can come up with the upper and lower bounds and then see what's happening, right? So let's say that, I have X, Y, something like this, and X is positive and negative, Y is positive and negative, right? So, okay, so if X and Y are both positive, then we are here. And what will happen in this case? What will the interval look like in this case?
AC comma PD.
AC comma BD, right? I mean, okay, so when I say X and Y are both positive, what I'm saying is basically that, let's say that, uh, the whole of the intervals are in the positive region, right? So A is greater than 0, C is greater than 0. So if A and C are both greater than 0, then we have AC comma BD, right? What happens in the case when A and C are both less than 0? Sorry, I mean B and D are both less than 0.
Maybe BD comma AC.
BD comma AC, is it? No, right? Because if B and D are both less than 0, that means what? Like A, B, C, D are all negative.
But like
Both X and Y negative. You'll have to take negative of this, right? So you'll have to go minus BD comma minus AC, right?
okay, why okay? Why minus? Oh, it's
No, because I don't know if I'm making a mistake, but like, so if let's say so let's say that this is AB, this is CD, something like this, right? So then, if both of my X and Y within this region, when I multiply them, and this is 0. So when I multiply them, they'll come over here, right? So of course, they will be uh, from the product of BD to the product of AC, but the values will be here, right? So it'll be somewhere over here where this will minus. Oh, no, no, no. Okay, no, no, you're right. You're right. Because
No.
B and D are both minus. Yeah, yeah, yeah. I was making a mistake. Sorry.
Mm.
BD and AC, right?
It just flips.
So,
It flips.
yeah. Yeah. And yeah, so now if, uh, you know, let's say that, so we'll have a number of such cases basically, right? So depending upon the kind of relationship between A, B, and 0 and so on, right? So let's actually do it this way. I think I'm kind of making it more complicated than it needs to be. Mess this up slightly. So let's say that we have something like this, right? So we have now let's say that we have this case where uh, AB is greater than 0 completely. Sorry, AB is completely less than 0, CD is completely greater than 0, right? So in that case, what will happen? So we have this kind of situation where we're saying that 0, A, B, C, D, right? So what is going to happen here?
BD comma AC to maximum of. Oh, okay. Okay. I'll think.
Yeah, it'll be something like
B
it'll
times.
go. Sorry.
The product will always be negative, no? Here,
Yeah, the product will always be negative.
negative. So
And the smallest absolute value you can see is if you do B times C. So that will be sort of the upper bound, right? BC is itself also a negative value because B is negative, C is positive.
yeah. And AD will be the least.
Yeah, AG will be the least, right? And then you have the symmetrically the opposite thing, right? So over here you will get the case where let's say CD is fully negative and AB is fully positive. Then you will have C. Uh, so you'll have AD as the upper bound and BC as the lower bound, right?
Yeah.
Yeah. And then we'll have the other cases where A and B, A, B, C, D, they all, AB contains 0, CD contains 0, and so on. So there's a number of other cases to consider as well, right? So here we've considered that AB and CD are all on one side of 0. But things like this could also happen where we have, let's say, CD is on one side of 0, but AB is containing 0, right? So we'll have to do these cases as well, which is probably too many cases to fit within the time of the class. But the point that I'm trying to make is that notice that each of these cases, the calculations aren't very difficult, right? So it's like you'll have to make a few. So if you were to implement this finally, the algorithm, whatever it looks like, ultimately the computation is going to look like making a few comparisons, right? Checking if A and B are both 0, if A is negative, B is positive, or if A and B are both negative, and so on. And based on that, you just have to make a couple of products, right? So when you calculate, okay, what is the interval for within which xy lies, ultimately this calculation is going to be just a couple of comparisons and a couple of products, right?
Yeah, but finally you
So
have to take a union, no? Because if you want to express the for all the situation, you can't do if then else kind of a thing. So if you want to express it as well, I mean,
I mean, what I'm trying to say is that yeah, you can kind of do an if then else based on the signs of ABCD, right? So we don't have to take a union
yeah, you don't
because
have to. Correct. You can
yeah,
keep
yeah, because
else. Mm.
right. Because I mean, in each of these situations, this is going to be an interval propagation, right? So, and we'll only be in one of those situations. We'll know exactly which situation we are in based on the signs of ABCD, right? So it's not like we have some ambiguity.
Yeah, that's assuming that these
But
things are constants eventually. Yep. Okay. Yeah. In any given situation, you know A, B, C, D. I mean, some constants, correct? Yeah.
right, I mean, so we know ABCD, right? So that what we know about X and Y is precisely that they are within
Function of
this
A, B, and C.
values A, B, and C, D. Yeah, and ABCD are actual values that we have in memory somewhere, right? So they're not symbols.
Yeah, that's the point I wanted to make. Yeah, to
Yeah, yeah,
emphasize in the class that you can precisely compute it for any given situation, value of A, B, and C. Yeah.
right. So I mean, just maybe one more case. So let's say that the case when A and B, AB contains 0 and CD is positive, right? So what will happen in this case?
Um, maybe, maybe you can ask a particular person.
Yes.
Huh? I mean,
Any guesses?
make sure that everybody is following. Abhinav, she's still there. Ganeshri.
So we have a situation where
No, I
A
just want to
is
make sure that these
less
people
than
are just not logged in and they're not in the class. I'm not even sure because they're
yeah.
not showing their face. I mean, if they're not answering, I'll assume they're not there. Ganeshri, are you there? I guess not. Parnika, are you there? I guess not. Abhinav, if you don't answer, I'll assume you're not there. and I'll just mark your attendance accordingly.
Is there something in the chat, perhaps? Yeah, there's some things in the chat.
Okay, at least Panika said that.
Panika said, I'm in the library, so I
she's in
can't
the
speak.
library. Oh, I guess there's only one person. Aritra is the only guy. Oh, is the only guy in the class. Okay, that's disappointing. Okay, so I think that's what I'll assume. Pranika is for all. She's listening, but she can't answer. So I guess you can continue. I mean, I'm recording it, so we cannot.
Yeah, sure.
This is terrible. Jane, are you there?
Yes, I'm in the text.
Excuse me?
Sorry, we can't hear you.
Bijian, I can't hear you. Oh,
he's saying yes in the chat. I think there's some audio issues perhaps.
Yeah,
Okay.
I was in the library as well, so yeah, I'm here.
Yeah, so Bijian, you're there. Abhinav just, he's cheating. So he logged in and he's not there. Gyanashri is cheating. Okay, fine. Kathakali, are you there? Okay, 3 people cheating. Okay, that's not very good.
Okay, so yeah, I mean,
go ahead.
just
we'll
just
have
very
to
quickly,
be
maybe
honest on our side. If they are cheating, then that reflects their character. That's all I can say. Yeah, please. So don't stop asking questions. I mean, you can ask questions, but I guess only Aritra is there and other people either not there or don't care to, can't answer. Therefore, you just lecture and finish it. I'll upload it and we'll move on.
Right. Okay, sure. So let's look at the case when AB contains 0 and CD is all positive, right? So here, what will happen when we multiply this interval AB by a value that is positive within C and D? We're sort of scaling this interval up and down by some value which is between C and D, right? So the smallest value that we'll see is when we take something from A and take something from D and multiply. So we again get AD. And the biggest possible value that we can see is again when we take something from B and we multiply it with D. So we again get BD here. So in this case it becomes AD comma BD, right? So again, I mean, we can write a bunch of if then else statements. So like ultimately, if you understand within memory, what we will have is we'll have some data structure that stores this value A and B for X, some data structure that stores this value C and D for Y, and these are actual values. And then we can write a bunch of if then else statements to understand which case we are in, and then within that case we'll get the actual values for X and Y, right, by taking the corresponding products. So the point that I'm trying to make is that it is kind of, algorithmically, maybe it's a difficult algorithm, but like it's a bunch of cases and you have to be careful. So it's maybe a bit tricky to write this. But once you have written it, at least for the interval domain, it is very fast to compute, right? I mean, I hope that everybody can sort of sees this, or that it's not very difficult. I mean, you just go through the case, if then else statements, you pick which case you're in, you group a couple of products, you're done, right? So it's maybe a handful of comparisons and products. So it's constant time, very small amount of computation. It's very fast to compute, right? So this is the point that I want to make. So we are losing information if you go back to the previous slide, but we're gaining something in it, when by giving up some information. What we're gaining is insane amounts of speed. Right? So if you come back and think about all of these other algorithms like Marabu and some of the algorithms behind Z3, I don't know if we have covered that in detail, but all of these algorithms are much more precise, but they're also doing a lot of computation, right? So Marabu is doing a bunch of LP iterations, a number of things, and all of that takes time, right? Here, you might not get a proof, but at least whatever propagation you do, you'll be able to do it within a snap of a finger. It's very fast to complete, right? So one last example, an actual neural network. Let's work through this step by step. And I think since there's still yeah, so I think there's since okay, so Kathakali is also here, but I think there's still people here. I understand if you're in the library, you can't speak, but maybe you can just write in the chat. Um, so yeah, so let's maybe work through this together, and then
No,
we
I
can.
think whether they're there or not, except Eritro, nobody cares to respond. So you just lectured, okay? And I
Oh, okay, okay,
recorded
okay,
it,
okay, sure,
and
sure.
maybe you can ask question, to Eritro, okay? If you really want to ask some question, I think, because I don't think
All right. I mean,
how many people are there, because they don't respond or do anything in the chat. So for all practical purposes, they are ghosts to me. Okay. Yeah, go ahead. Sorry. I apologize on behalf
no,
of
no, no, no,
you.
it's okay. So yeah, so let's look at this example, right? So you remember we had sort of very briefly introduced this working example, and the idea was we were going to use this in a couple of different situations, right? So here what do we know? We know that for these variables x1 and x2, the intervals are going to be -1 and 1, right? Okay. So then what is the interval that x3 is going to be in? So x3 is going to, again, x3 is x1 plus x2. So it's going to be within -2 and 2, right? Similarly, x4 is going to be within -2 and 2 again because it's x1. Sorry, it's x1 minus x2, right? So x3 and x4 are now going to be within -2 and 2. And immediately you see that we have lost some information. X3 and x4 are related. So for example, x3 and x4 can't both be 2 together. But we are not able to keep track of this when we do interval propagation. We can do this very fast, but we have lost some information, right? So now what happens when we go through the ReLU? So when we go through ReLU, what is the interval that x5 will be in? We know that it will be between 0 and 2, right? So similarly, x6 will also be between 0 and 2. And then the conclusion that we come to via interval propagation is that x7, which is x5 plus x6, is going to end up being 0, 4, right? And again, if you go back, what we wanted to prove about this network is that x7 should be less than equal to 3. And we don't have that, right? So the interval is not sufficient to prove that x7 is always less than equal to 3 because we have the value 4. On the other hand, this value 4 is not an actual value that can appear in the network because the only way we can get 4 and x7 is if we get 2 in x6 and 2 in x6, which can only happen if we get 2 in x3 and 2 in x4, which can now to get 2 in x3, x1 and x2 need to be 1 and 1, whereas to get 2 in x4, x1 and x2 need to be 1 and -1, right? So this is something that can't act.
Hello. Hi, Diganta. Um,
Am I audible now?
yeah, but there is a lot of background noise.
Oh, I see. Let me see.
Better now?
Yeah, Slav. Yeah, it's just slightly better.
Okay, okay.
Yeah, it's better now.
Yeah, you'll have to give me host permissions again, unfortunately. I think because I rejoined, I'm not host. Uh, Hello?
I think, can you hear me?
Yeah, I can hear you. I can hear you. I'm saying that I'll need
I'm
to
not
be.
sure. I can't see your screen or anything. Okay.
No, I can't share screen because I'm not host.
Yeah, but I can't even.
Oh, has
Just a
something
minute.
gone
Just a
wrong?
minute.
I hope that me leaving while I was host did not mess things up too much.
I think it might have because I don't
I see.
make you co-host.
Yeah, I think I'm co-host now.
Yeah.
Okay, maybe
Yeah,
let me
I
just.
think those people are there. Yeah. Yeah, they're there.
Yeah, I think. Yeah, I mean, I'm willing to at least understand if people are in the library.
No, they're not
I
answering, so I cannot believe them that they are in the library because at least Pranika was honest enough to type something in the chat. For
I think a
others,
couple of other people
yeah.
did as well, if I
Huh?
remember. But yeah, sure. I saw a couple of other messages in the chat as well, actually. But
That they didn't say that they're in the library though.
okay.
Yeah, I don't like the way that with so many disruptions and so on. I'm not even sure if there are any people there and they refuse to answer. Is anybody there on the meeting?
Yes, sir.
Yes, sir.
No. You just tell your names, please. Okay. So I can't see you, therefore you don't have pictures, and therefore at least
No.
be courteous enough to announce your name. I almost
sir.
take the attendance. Okay, let me see. Okay. Abhinav, are you there?
Yes, sir.
Huh?
Yes, sir. I'm here.
You showed up after I yelled and screamed. Okay, why didn't you answer the first time?
Oh, I just went out to the
Okay,
washroom.
okay. Good enough. Aritra is there,
True,
I'm
though.
assuming. Yeah? Aritra, are you there?
Yes, sir, I'm here.
I
What?
think you had answered. I mean, you had said something a long time back as well.
Yeah, he did, but right now.
Yeah.
Bijayan, are you there?
Yes, sir. Yeah.
Janishri, are you there?
Yes, sir.
And you never bothered to answer earlier, huh? Why was that so?
I'm sorry.
What do you mean you're sorry?
I got distracted for a bit. I'm
You got
sorry.
distracted from what?
I had to go out for a bit.
Is that how you do if you're in the physical class? Okay, so maybe okay, then I think I'm going to cancel the class today, Diganta. Okay, because I don't know. I mean, either we will they don't seem to be taking this thing very seriously, and since I cannot monitor this thing, and since they are cheating, okay, they're walking in and out, waltzing in and out as they feel fit. It seems like they need a physical class where I can actually keep tab on them. Okay, I thought I could trust them, but I don't seem. It doesn't seem like this is a class worthy of any trust. At least the way that they're behaving today. So I'm going to, from next time on, probably I'm going to make a physical class. Okay. And I'm very disturbed. Okay. And it's not worth, I don't feel like imposing on you, Diganta. okay, when the class doesn't seem to care. It's kind of waste of your time. And therefore, I don't know what to do.
I'm fine with whatever you decide. I think.
Yeah, I'm thinking.
So, I mean, now that people are here, can I ask something? Like,
Yeah, please go ahead. What do you want to ask him?
no, no. I mean, I'm just wondering, like, if you can be honest for a sec. Like, I mean, do you
If
think that this is relatively like, am I going too slow and therefore it's not like too interesting and all that, or because in that case I can change things up a bit and go a bit faster and so on. Like I understand if this is too slow or something like that for you. I mean, of course, it's hard to speak up and say it's too slow because there might be some other people in the class who don't find it slow. So is there anybody who finds, okay, what do you think guys think about the pacing in general? Is it too fast, too slow?
So it's fine with me at least.
yeah, Ritra,
I think it's fine.
you're the only one who's seemed to be interested and
I
honest.
don't call me
The
sorry. I
other,
mean, yeah,
the other people are either they're dishonest or uninterested or don't care. I don't know because they don't even answer. Uh, and I think they have to do something to fix this, to escalate this or something. Um,
yeah. So the only reason why I am asking, you see, I'm not that like senior or something. I mean, I'm very happy to be here and talking to you also. I would really love some like honest feedback because it would help me understand how to give lectures better, right? So don't call me sir or anything. I'm not that like you know. I,
no, there's no,
but like
there's no such thing here. After all, they'll have to present when they present the papers.
right, right.
They will be the owners of that, okay? And I thought that the whole purpose of this kind of paper presentation thing was that I was assuming that
Hello.
there's some level of maturity among these people, and I think I have underestimated their maturity and honesty and sincerity is what I can say. Why should you apologize for being? I mean, you graduated from here and then gone, so that's no reason
Yeah.
to.
Sorry, I think Vinay was saying something. Like,
Nothing, I was saying the pace is fine.
Now, how can you even say that, Abhinav? Were you there?
So
You
yes,
don't
I
show
was
up for
always,
half
I
the
was there,
class,
I was there, I
half the
was
number
there.
of class, and I can't even be sure how long you stayed in this class. Why should I believe you? Anyway, we have to take it for whatever the worth is.
yeah, okay, sure. So what's the plan now? I mean, I can go on or we can try again next time.
Yeah, I think we should try next time.
Sure, that's
Yeah,
fine.
but
But
if they still don't show up, I'll assume that will be a terrible thing to do. I never done ever in my class. We'll have to assume that they know. I mean, that we have lectured. If they don't show up or if they don't care to answer, then we'll just have to say that we are done lecturing, and I'll. Oh, yeah. And no, let's come to that. Okay, so. What is next Tuesday?
next Tuesday, let me check. Next Tuesday is first.
Yeah, we think we'll have to retry next Tuesday. I think this has been a terrible and bad experience for me overall. So I will, yeah, I will resolve this. Okay, first by chatting with the class, and then probably escalating this thing, and what is the best way to proceed forward with this situation that we are in. Okay. So next Tuesday we'll meet, and that'll be a physical class, although you will be joining remotely, Diganta.
Yeah. I think that also works for me. I mean, yeah. So I think there's last time there were some technical issues with that, which is why you shifted online, if I understand right. Like fully
No, it
online.
had to be online because you are remote. It had to be online. No.
Right.
Today it was exclusively online because I'm not in town. Okay.
Okay.
That's
Yeah,
why.
sure.
That's why. And I didn't think that people would cheat. Okay. Deepro just waltzed in right now. Okay. This is amazing. I'm not sure if he was even here. He just walked in. Okay. This is so unprofessional. They walk in and walk out anytime they feel like. This is terrible. I'll have to do a few things. Yeah. So let's meet Tuesday, and I'll be in touch. And I apologize.
No. I mean, there is really no. I mean, I'll be honest. I've been on both sides of this. I kind of understand, but like, if people here are feeling that it's
Maybe
going to slow
something
or
is
it's
wrong.
boring or
I
whatever,
think
then you
I
have to
think they
say something, because otherwise I have
can't
no clue.
track the web. Maybe that they I will also ask them, guys, if you're not interested in attending classes or the thing, you should complain. I mean, you should be honest enough to say that we don't want to attend. It's the first time that has happened to me ever at CMI, where someone signs up for the course and then hardly shows up, or they do these kinds of cheating on online class. Okay. Some people have the gall to say that they got distracted. They got distracted with what? Swiggy? Oh gosh. Okay. So I'm going to end this, and I'll take a poll of the class. If they really want to have any classes, and how many of them, even if there are probably, I will make a decision as to how we should move forward. Yeah, next Tuesday. Thank you.